Good morning, guys. Welcome back for another edition of Cream, Sugar, and Calmag. Took a few days off because I didn't want to really just skip over the whole nutrient thing and plant essential elements, and especially because I really wanted to get the guests on. Speaking of guests, we have our guest for today. Let's see how that'll work. There we go. We are now live with Mr. Neil Watson. Good morning, sir. Oh, we can't hear you, Neil. Oh, technical difficulty. We can see you there. Oh, hold on a sec. We'll get it going here, guys. Yeah, so this morning we're, oh, there we go. Perfect. Welcome, sir.
Okay.
Everyone, this morning we have Neil Watson from New Millennium Nutrients joining us, and he's going to do a little talk and educating us on the plant essential elements. So I'll give the floor to you, sir. And
Okay, sounds good. Everybody, I first heard about this from our colleague Lee McCall, and he had mentioned that Robin wanted to kind of do an Instagram series on individual elements for plants, and immediately what popped into my head was there needs to be kind of an overall overview of all of the plant essential elements, and then I would just single one out after I rattled all that stuff off. So bear with me for a second. I'm just going to be staring at notes rather than into the screen for a couple of minutes. Plant essential elements are almost identical to animal essential elements, and I'm going from memory from I went to ag school over 30 years ago, so I get it almost right, but I might miss a minute hair-splitting detail or two. And for those of you who know more than me, I recommend you get your own show with Robin one day and correct my errors.
there we go. The offer stands, folks.
And so basically, what's in all plants that were deemed essential in my soils class over 30 years ago are oxygen, hydrogen, carbon, nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, iron, manganese, copper, zinc, boron, molybdenum, chlorine, nickel, and cobalt. Nickel and cobalt were kind of on the fence whether or not they were truly essential. I'm not sure. And what is also in virtually every plant that may or may not be truly essential are silica and aluminum. And just as a side note for aluminum is a basic component in virtually every clay particle. Clays are thought of as alumina silicates. And that also is where the silica comes from in normal soil on the earth's thin skin of soil. Now in animals, animals need a trace of sodium, selenium, and iodine, and plants don't need them. And sometimes they'll have salt licks for animal production, like beef and swine and lamb and poultry. Now basically, oxygen has a physical characteristic of weighing 16 on the periodic chart, and the way the number 16 comes about is as a result of a mathematical equation where you multiply Avogadro's number to basically how many, well, let me just say, let me go to page 2, not get ahead of myself. Avogadro's number using scientific notation is 6.022 times 10 to the 23rd. And that number basically looks like this, if you can see it. I imagine that it is hard to see.
Lots of zeros.
Let me put it in the sun real quick. Let's see if we can figure this out. Yeah, you aim that, and I'll aim this. There we go. See all those zeros? That's Avogadro's number. That's how many atoms of oxygen it takes to weigh 16 grams. So that's basically 6022, and then you've got 19 zeros to the right of it. And every element on the periodic chart has an atomic number, like oxygen has 16. And all of the plant essential elements, starting with the lightest hydrogen, weighs 1, carbon weighs 12, nitrogen weighs 14, phosphorus 31, potassium 39, calcium 40, sulfur 32, iron 56, manganese 55, copper 64, zinc 65, boron 11, nickel 59, cobalt 60, molybdenum 96. So anyhow, they all have their individual physical characteristic of their mass when you multiply times Avogadro's number. So that's just the basic foundation of all the plant essential elements. And a plant is generally 90% water, approximately. And water is 2 hydrogen atoms and 1 oxygen atom. And there needs to be a little bit of what they call free oxygen in water for plants to get oxygen for their roots. And that is in a range of 6 to 8 parts per million. That's a healthy range. So for every 6 to 8 pounds of free oxygen, you've got 1 million pounds of water. So that isn't very much, and that's a very narrow range. And let me just refer back to a note real quick. Okay. So basically, if you drop down to 4 or 5 parts per million free oxygen in water, then it influences a different class of microbes, which are called facultative, which operate on low levels of oxygen, and they are often pathogens. And then if it drops below 3.5 or 4 parts per million, then you get into anaerobic microbes, and they are almost all plant pathogens, and they will give you root diseases, with the exception of nitrogen-fixing bacteria. They happen to kind of have a thin skin of the plant root above them, and they work in an anaerobic environment, and they're able to make nitrogen available from the Earth's atmosphere. So plants that are legumes like beans or peas, they are able to get nitrogen from the Earth's atmosphere. And so basically, oxygen is the atom, the plant essential element that the lion's share of all of the plant essential elements revolve around. Some people may argue the point that carbon is, because carbon is the essential element which is in every organic molecule, and probably you may want to get an organic chemist to do an episode with you to discuss all the ins and outs of carbon. So I would certainly defer to the wisdom of somebody that knew more about organic chemistry than I do, if they argued the point that carbon is more essential than oxygen. And for right now, I kind of want to broaden the conversation or the monologue that every plant essential element is absolutely essential in its own concentration relative to the concentrations of all of the other essential elements at any given instant in a plant's life, in a plant's life cycle. Just to give you an idea, when a plant tissue lab analyzes plant tissue, they dry out the plant tissue so that they refer to it on a dry weight basis. And I've seen nitrogen and potassium levels in tomato tissue, for example, to be up near 12 or 14,000 parts per million. And that would be on a dry weight basis. When it's on a dry weight basis and the lion's share of the water is dried out of plant tissue, the dominant essential element at that point is carbon. And so basically of dry weight plant tissue, carbon is approximately 90% of what goes into plant tissue. And so if you're at 10,000 parts per million, that's 1%. 10,000 parts per million is the same thing as 1%. So if you're at 12 or 14,000 parts per million, then you are 1.2 to 1.4% nitrogen. Now, to complicate things even further, when a government agency analyzes a fertilizer, they look at nitrogen in forms of available nitrogen for plants. And those forms would be nitrate nitrogen or ammoniacal nitrogen or organic molecules of nitrogen. And when they say ammoniacal, they either talk about ammonia or ammonium nitrogen. So there are several different levels of nitrogen, several different forms of plant available nitrogen, and they only count the nitrogen part of the ammonia, ammonium, nitrate, or organic nitrogen levels of those proportions of the plant tissue. So anyhow, if you want to get into the nitty-gritty and compare apples to apples or oranges to oranges of the various nitrogen molecules, then you have to specifically identify what you're talking about so everybody in the conversation's on the same wavelength. With nitrate and with organic molecules that have plant available nitrogen in them. There is oxygen in those, but ammonia and ammonium only have nitrogen and hydrogen in those molecules. So they are available because of the energy that is in the hydrogen, or the energy that is in the oxygen in the case of nitrate. And the nitrogen in the Earth's atmosphere is an atom, is actually two atoms of nitrogen. They call it N2 with a triple bond, which basically means there are 3 electrons that the 2 nitrogen atoms are sharing. And so the lion's share of the nitrogen in the Earth's atmosphere is basically not available to a plant. So a laboratory that tests for a government agency to see levels of nitrogen in a fertilizer, for example, the government will not acknowledge that that nitrogen is available to the plants. So you can't be selling Earth atmosphere as fertilizer. And a similar situation goes on with the case of phosphorus. When somebody buys what they call single superphosphate, which is often the apatite molecule, which is a mined ore, basically a phosphorus deposit in the Earth's crust out of a quarry. Most of the phosphorus in apatite is not considered plant available. So when the government tests for that, they may only say it's 12 or 13% phosphorus. There is quite a bit more phosphorus in it. It's just not available to plants. So the government doesn't want you to be misled about how much phosphorus is available. And when a fertilizer company sells phosphorus and you see the analysis on the label, the N, P, and K on the label, you'll see phosphorus identified as phosphate or phosphoric acid. In the case of phosphate, you've got 1 phosphorus atom and 4 oxygen atoms. And in the case of phosphoric acid, you've got 2 phosphorus atoms and 5 oxygen atoms. And with regards to potassium, plant nutritionists or agronomists or whomever, they look at it in terms of potash. And oftentimes people will use the term potash. And that actually comes down from, they used to spread ashes, from burn piles on gardens, and they would get a plant response from it, and it was largely potassium. And potash is actually 2 potassium atoms and 1 oxygen atom. So in a nutshell, nitrate would be NO3, phosphate would be PO4, phosphoric acid would be P2O5, and potash would be K2O. And the oxygen associated with all of those different what they call major nutrients in plants, the oxygen makes available to the plant the nitrogen, phosphorus, and potassium. And so that's a case where oxygen can make fertilizer more available to plants, and oxygen can also tie up plant nutrients. For example, iron oxide, which is most commonly known as rust, is not available iron to plants. And it happens to be basically FeO, iron oxide, or ferrous oxide. And in the case of lime, lime happens to have 2 carbon molecules, 2 hydrogen molecules, a calcium molecule, and 6 oxygen molecules. And that is largely unavailable. And it actually has a parent compound, which is CH2O3, which happens to be carbonic acid. And in a soils course, they'll have a lab where you blow a straw of your breath into water. You test the water pH before you do it, and you test the pH after you do it, and you'll notice that the water gets more acidic from the exhale of your lungs. And that is basically CO2 from your breath plus water making carbonic acid. And that is especially pertinent to those of you who supplement with CO2. In an indoor growing situation, if you boost your carbon dioxide from a normal atmospheric level of 350 to 450 parts per million carbon dioxide to maybe 650 or 700 parts per million carbon dioxide, that can make your irrigation water more acidic, and that is not truly healthy for your roots. And that's a great segue to talk about what plants do for their metabolism. Plants both respirate and transpire. And transpiration is the byproduct of photosynthesis, where you've got light coming down to the leaves, which are the solar collectors, and the leaves transform the photons from the light into energy. Well, yeah, it transforms light energy into, I would assume, electrons, and electrons, like a photovoltaic panel, can split water molecules, and so basically the water molecule, being H2O, becomes 2 free hydrogens and a free oxygen. And so that only goes on when it's light, or in for all practical purposes, the green part of the plant, when it is exposed to light, it transpires or transpirates. And simultaneously, a plant will respirate. If you buy a bag of salad mix and put it in a dark refrigerator for 2 weeks, it can puff up the bag, and that is respiration, and that's giving off CO2. So when the conditions are light conditions, you've got both transpiration and respiration going on. And in dark conditions, you only have respiration going on. So a plant will make free hydrogen, free oxygen, and CO2 all at the same time when it's exposed to light. Now, since roots are not typically exposed to light, they only respirate or respire, and that is an off-gassing of CO2. So roots have a natural affinity to acidify their soil ecology, or in the case of aero or hydroponics, they can acidify water. Now, microbes can cause it to swing another direction, or intensify the acidification as well. So so roots are not the only thing impacting the root ecology's pH. And I probably ought to touch upon what pH is for a second. pH is basically what they call a logarithmic scale, where the scale goes from 0 to 14. And I'm going to try to show you all the zeros in the pH equation too. I don't know. Is that coming up? Can you see that on the screen?
Yep.
Okay, so there's a whole bunch of zeros there. When you are at a scale of 14, that's basically, that's all alkalinity. And when you're at a scale of 0, that's all free hydrogen. And so what we're talking about is a balance of H's to O's in water. That's what pH is a product of. At 7, you've got all complete water molecules. At 0, you have all hydrogen molecules or atoms. And at 14, you have all what they call hydroxyl molecules, which is OH molecules. And everything in between 0 and 14 is basically a measure of hydrogen atoms to hydroxyl molecules. And so 0 is perfectly balanced water, a healthy root range for a general root ecology is somewhere probably between 5.6 and 6.8, which basically means it's mildly to moderately acidic. And all of the different plant essential elements have their optimum pH for availability to roots. So just off the top of my head, phosphorus is more available closer to neutral or a 7 pH, and a metal like iron is more available at a lower pH. And every element has a sweet spot for pH. And so that's how oxygen is important to making all the other essential elements available to plants.
The one thing I just wanted to say, the media factors into that though, right? Because
absolutely. And I'm glad you brought that up. What goes on in the Earth's crust soil, which has got a fair amount of mineral component, sand, silt, and clay, and plus organic matter, is typically what they call a nutrient film of water. Basically, the film of water is, from a proportional standpoint, most attracted to organic matter and clay because there's more surface area in organic matter and clay than there is to silt or sand, because silt and sand just has proportionally minuscule amounts of surface area relative to the others. And the surface area, the attractive force between the surface area of any of those components and water is what they call adhesion, adhesion. And water attracting to water is called cohesion. And so basically, in water, you have that upper limit of dissolved oxygen at about 8 parts per million, depending upon how warm it is and the elevation where you're growing your plants, basically the atmospheric pressure. And just one other quick segue. There's a phenomenon or phenomena in physical science called universal gas laws, where you've got influenced by temperature and pressure. And so the best way to think of it is the boiling point of water at sea level is about 212 Fahrenheit or 100 Celsius. And the boiling point of water at a mile high is basically about 170 Fahrenheit or maybe 88 to 92 Celsius. And the same thing goes on with minuscule amounts of oxygen in your nutrient film of water. So the warmer your aerohydro solution temperature is, the less dissolved oxygen you can have in your water. And so you really want to keep your water temperatures at that sweet spot range, probably between 68 and probably 76 Fahrenheit. I don't know what that'd be Celsius off the top of my head. What would that be, like 26 or so? Anyhow, so if your water is too acidic or too warm or too cold, then that can encourage or discourage your complementary microbes. And so that could either infect your roots, or it could create beneficial conditions where the plant essential elements can get into the root systems better. I'm going to have a sip of water. Somebody else can talk.
Not a problem. Actually, here, I'll while you're having your sip of water, I've heard as far as too cold, once you start dropping below 60 degrees Fahrenheit, you'll start locking out magnesium and phosphorus. Is that true?
It's likely something going on, both from a energy level, a heat energy level, as well as favoring different microbes. So yeah, I would say that's likely the case, as well as the influence of how much acidity you have versus alkalinity in the water.
Oh, okay. Interesting. Wow. You've I don't even really know where to start. You've dropped so much knowledge. There's stuff I wanted to comment on. Now you've mentioned like 6 other things since then.
It's heavy duty, and I do want to interject at one point. I have my favorite university professors that put me to sleep listening to YouTubes, and I literally listen to them over and over and over. So if this is too much all at once, literally step away from it and watch it again.
That's my exact approach to this. I like to bring people on that are very knowledgeable and experts in their field. I like them to lay out the technical. Sometimes you can drop like a little put it in the layman's terms afterwards, but I encourage people to use the technical terms and whatnot, because this will be saved. And me, like many of my followers, will be loading it up, watching what you said, pausing it, looking it up in the internet, and coming back. So
yeah, and I'm sure you'll find a few things I said in error, and probably in 100 years they'll completely consider it a fallacy. But that's my understanding of where we are using Western science.
Okay. Well, sticking on the subject of pH, one of the people in chat, Wolverine Grown, says, would you recommend alternating pH? Because some people like to do the pH swings, like water at 5.8 first, then 6.3, then 6.0, then 6.4, or do you prefer static?
I don't even watch it, to be honest with you. I should. And those who grow with meters, they should learn their benchmarks of what is good, and mostly use their eyes as instruments. Excuse me, to see how the leaves look.
Uh-huh.
If the leaves look good to you, you're probably well within the infield of the ballpark. If things start to go wrong, then refer to your instruments and see how they're varied compared to your benchmark of what looks good.
Very, yeah, and that's kind of where I'm at. I'm a read the plants sort of guy, and kind of go from there, right? If they look a little hungry, chances are they're a little hungry, and
yeah, and
bump the EC point too.
A very good friend of mine who's about the best grower I know. I learned a comment from him years ago. It's better to be on the edge of starvation than beyond the point of toxicity for a plant. Because with our growing techniques, we can play catch-up ball with nutrition very, very rapidly. With a foliar or just boosting your concentration of your nutrients. For sure, if your pH is off, your leaves will tell you that. And so you may not know what direction your pH is off, but if all of a sudden you start seeing some kind of yellowing or some kind of deep maroon coloring going on, check it with the pH meter and see where you are.
See, I've always kind of been like, if I'm checking runoff, I'm checking usually the TDS, because I find a lot of times the pH is a symptom, not a cause. So, like if I look at and I see my runoffs coming out heavy, I know my pH is probably low, because it's more, like the more nutrients, the more acidic, right? And whatnot.
Well, often, but not always. But yeah.
No, that's true. That's true. Yeah, and like Wolverine Grown said, usually more runoff just usually fixes the situation, just giving a little flush out of the root system.
Yeah, you can find 100-year-old plant growing literature showing you that if your water's too salty, then you should probably be overwatering 20 to 30%. So 20 to 30% more than what the plant needs should be coming out of the bottom of into your catch pan.
Love it.
And if your catch pan keeps, well, you're reading using your pH meter, if the salt levels keep increasing in your catch pan, assuming you empty your catch pan constantly, then you're underfeeding. And using our Ruby product, if you are in a situation where all of a sudden, let's say you were feeding at 750 parts per million, and your runoff water read 950 to 1150 parts per million, then you may want to just clear water feed one day with 1 tablespoon per gallon of Ruby. And so basically what you're doing is just flushing through toxic levels of fertilizers.
Right, because yeah, no, I've run Ruby for 2 years, and I read that if you do run into issues, you can double it up, and it works really good to either break up the ionic bonds and then also make that stuff available to the plant.
Yeah. Now, I typically feed 600 to 750 parts per million. Some people may think that's light. Um, in let's say the mild conditions in British Columbia, people might want to be feeding 11 or 1200 parts per million. In harsh conditions in like the Arizona desert, you may want to be feeding, 450 to 550 parts per million, just because the plants are needing so much more water.
That they take up excessive nutrients.
Yeah, but the thing is, if you're gaining with your runoff water, then basically feed ruby only until your levels come down to what you normally put in. Once your levels are back down, then you can start feeding again.
Yeah, no, that makes sense. That makes sense. And I found, like you were saying, it's better to underfeed your plant and do a slight correction
Yeah,
versus the toxicity, which I find really retards the plant and just stops growth
yeah,
sometimes when it gets bad enough.
and once you have necrosis or dead brown leaves, they never repair themselves.
Right.
You may have new growth coming out of the meristem of the plant that it can become healthy and vibrant again, but once you've got those chlorotic splotches or tip burn, it never reverses. So if you're going to err slightly on the underfeed side, and then um, basically proverbially put your big toe in the water with feeding them a little more robustly, and see how the plants respond.
Yeah, absolutely, absolutely. And I find like I do a lot of leaf stripping, like
Stripping.
like pulling the fan leaves off.
Okay. Yeah.
And I find in a case of toxicity that actually helps reset the plant because now they don't have the toxic levels built up and they kind of
Yeah.
it helps them transition to pump out new
And
growth that's
and
proper.
what you're doing is allowing more airflow access to the healthy parts of the plant. When you strip out the leaves, you need that normal process of evapotranspiration, or I'm sure many of you use fans and literally blow air across the surface of the leaves,
Yep.
and dead plant tissue will definitely screw up the airflow.
Yeah, for sure. I just want to kind of switch gears a little bit. We sort of touched on it a little bit, and it's really like the hype right now is silicon.
Uh-huh.
It's not considered plant essential, like you said, but if you look at the biochemical sequence, it does promote the uptake of all other elements.
Yeah,
Um,
it does that. Both silica and potassium, they have an affinity to make a plant's structure more rigid, and they can make it tougher for chewing and sucking insects to do damage as well. Um, I remember going visiting Bloomington Wholesale, which was BWGS down in Bloomington, Indiana years ago, and I saw a trial going on with silica, and the plants with silica versus the plants with control were absolutely night and day. It looked like it was a different variety. The plant was just so much, more strong.
right? Not plant essential, but it should be.
Yeah, yeah. At minimum, very complementary to the plant.
Yeah,
And
absolutely.
you really, if you're using soil from the earth, it's very difficult to keep silica out of the plant, because it's in every clay particle.
It's
Same with aluminum.
right. I think I've read silica is the second most abundant element on Earth in the crust.
Could be. We were not going to run out anytime soon.
Yeah, yeah,
Yeah.
absolutely. Wow, this has all been great and very interesting. I'm not sure how much time you have if you got to get running. We kind of covered all the elements and gone through everything, and
Yeah.
about the
But
plant function.
I do want to say, still, I encourage you to get experts in all the different elements to specialize in them for different shows.
Yeah,
That's
absolutely. While I got you here, and since you are from New Mill, and I know it's a huge part of your line, I was wondering if you could maybe just touch a little bit on organic chelation while you're here.
okay.
I know it's a big topic and whatnot, but
Yeah. Let me just kind of break that down a little bit. I'm referring to something a retired professor of University of California, Santa Cruz told a former colleague of mine and I once. Um, Chelation comes from the Greek um, translation of claw, and water naturally claws positively charged plant essential elements such as iron and calcium. And those are the most challenging of the fertilizer plant essential elements to get into a plant. And so basically, in the absence of a chelate, what we think of as a fertilizer chelate, like EDTA or citric acid or something, water will claw the iron or the calcium harder. It'll have a tighter grip on it. And so you had mentioned the term organic in scientific terms. Organic means it's a molecule with carbon atoms in it. So chelates with carbon atoms in them basically loosen water's grip on positively charged plant nutrients.
that makes a ton of sense. And one thing I've read and noticed is if you keep your media over wet, that's the two elements you have the hardest time taking
Okay,
up is calcium and iron.
that's a great cue of something I wanted to mention. I remember handling many tech support calls talking to people about overwatering, and I ended up just telling people plants do not drown, they suffocate. And if you've got a soil media or water that's too hot that your roots are in, um, it's not hospitable for available oxygenation for the roots. And since the roots are putting off CO2, they basically just displace all the free oxygen. And also, microbes can gobble up the free oxygen. And so basically, it's not that there's too much water, it's that there's not enough oxygen as a result of there being too much water.
Right. And it's a balance of the two. They're like
Yeah,
Slow Nickel is an agronomist I follow, and he always says oxygen's the most important element at the root zone. And
yeah,
it's really I find the balance between the two and whatnot. Like you can use like touching back on chelation, like glutamic acid or glycine will help promote calcium uptake, and lots of microbes produce siderophores, which will boost your iron uptake. So there is ways you can boost that and counteract it and
yeah.
promote the uptake. That's
Um,
really what I like. Like I like, first you find your feed and you find your elements that the plants need, but then it's about increasing the uptake using humates and
okay.
inoculants and biostimulants. And that's why I run your guys' line for 2 years now, and I'm like a believer. I tell people Ruby Fulvic is one of my favorite gardening products ever, right? Like it's just,
Good to hear. Good to hear.
well, I'm not going to name any names, but I used a rival company's Fulvic, which was 20 milliliters a gallon. And I finally switched over to Ruby at 5 milliliters a gallon and saw like at least double the effect I was seeing of the other product. Like it's a solid product. And I'm actually, for those of you who don't know, we will be bringing New Mills products up here. We'll be the first shop in Canada to have them on the shelf. And pretty excited about that.
That's great.
Yeah, absolutely.
Well, we'll have to go up and see you.
Absolutely. Lee and Jaron, those guys have all said, you know, they got to come up here once COVID and stuff's over. So, pardon me. One last thing. It is the Gateway Jug. I would never be forgiven if I didn't let you talk about winter frost at least before you had to leave.
Winter frost. Well, let's just say the original incarnation of the company was both known as Millenium Garden and Life Circle Hydroponics. And it had a name. Winter Frost had the name Twilight. And to go along the theme of the annual life cycle, you start with spring, go to summer, go to autumn, and then you finish up with twilight. And some very good friends of ours who are fantastic tattoo artists that did our original New Millennium artwork, they felt that, and I'm not using their words, but I'm paraphrasing notions. They felt that winter just kind of flowed better than twilight. And of course, the original name Twilight, we were kind of thinking about the nuances of the Twilight Zone, you know, the twists of the Twilight Zone. So it was kind of in our own minds, a comical twist on the name. But basically, the entire line of nutrients is patterned upon what goes on in a Mediterranean-like climate. And we first developed the line of product on the central coast of California. Mediterranean climates are like around the Mediterranean, parts of Australia, parts of Chile, where you have, in California's specific case, a statistically guaranteed drought between May Day and Halloween. So in the spring, you've got fresh soils from a rainy season, and the soil ecologies function real well, and then you have your warming days of summer and increasing day lengths, and then you hit your summer solstice, and then days taper down, and your day lengths shorten. In your soil ecologies, especially if you irrigate with alkaline water, get worse and worse and worse.
Sure, stop for a sec there. Have some water if you need to take a break.
Okay. And the root systems struggle towards the end of the growth cycle, and basically the plants protest, and so we basically designed the product to simulate what goes on in Mediterranean earth soils, so we could do it in containers. So it's
cool. Can you talk a little bit just about its effect, what it does to the plants? Like, why, as cultivators, is it, like, I like to say it's cheating.
It makes
Talking
it
with Lee,
matter.
I joke about like I don't want to tell anyone about this. This is my secret weapon, right? But yeah, no, it's a
Yeah,
great product because you can visually see it working after
good.
3 or 4 days. So
Yeah, they're irritated. They're going. Um, one of our original mentors used to say, you don't want to feed a baby Enfamil or a elderly person Gerber baby food.
right,
So you basically adjust the diet according to where they are in their age, and at the end, basically, we feed them food that is hard to metabolize, and they get irritated, and basically produce results. It's kind of like right after you sneeze, your nose runs and your sinuses clear
yeah,
up.
uh, awesome,
But I mean that's just symbolically speaking. That's not literally what's happening in the body.
right. And I know from using the product, it creates like an oil response. Um,
That
I
can
heard
happen.
people saying that the trike heads swell up to 3 times their normal size, which I haven't done any studies myself on, but I know from seeing someone that was running a strain that had already pretty fat heads, and then they did a wash with it, making bubble hash, that all the heads got captured above 180 microns. So
Hmm.
they were like large and swollen, and normally they're much smaller. You catch them in the lower microns and whatnot. So it's cool. It's a product that works.
Huh.
I'm jacked to get it up here and get it into people's hands. So
All right. That sounds great.
awesome. Well, I should let you go. I gotta fire up the hydro shop here, and
Okay.
we've man, you've dropped so much knowledge on us. I just want to thank you very much for coming onto the show, and thank Lee and Jaron for help making this happen. And my best to you, sir.
Okay. Well, just out of curiosity, I'm being, just losing my Instagram virginity. Um, is there a way to pull this up, or is it gone once we're off the air?
Yep, no, absolutely. I will save this to my timeline, and you can watch the whole thing in its entirety. The only thing that'll change is it doesn't save the chat that's scrolling across the screen. But yeah, our whole
Okay.
interview will be saved for the age.
Very good. Okay.
And
Thank
actually,
you.
I found a way to download off Instagram and save this, so I can actually save this file of this video to back to Lee, so you guys will have it as well.
Excellent. Well, happy gardening, everybody, and thanks for tolerating me.
Oh man, it was a pleasure. It was an absolute pleasure. Thank you so
Okay.
much.
You
Okay,
bet.
have a great day.
You too. Bye bye.
Bye bye.